So after a long wait, OCI finally came out with some 1.1 releases back in February, and if you follow the OCI project at all, that's kind of a rare thing that we ever do releases of stuff. So I want to talk about what went into it, but first, just a quick background for anybody that's not familiar with it. OCI stands for the Open Container Initiative. They are under the Linux Foundation. They are not a CNCF project. They are a sister project to CNCF, also alongside of like OpenSSF. So you got a couple of these foundations and projects under Linux Foundation. This is one of those set aside. And what we do is we define the specifications that containers use for how you package these things up, how you run them, how you ship them. So first thing we did this past year is we defined what an artifact is. And so as we just saw from some of the gadget stuff going on there from the inspector gadget, if you've ever packaged up a Helm chart, some of these other things you pushed up to a container registry, you can ship those alongside your images in the same repositories. And what we did is we standardized how you can do that and use the image spec to ship those. Before we kind of had some other guidelines and whatnot, now we properly put it into the spec itself. And part of that, we defined what an artifact type is in there, and we also defined what an empty blob is, because there's a lot of cases where you're shipping around pieces that are required in the spec, and you might not have it within your artifact, and so we defined how you can null those fields out. We also defined the data field. I think I skipped something here, didn't I? No. Okay. We also, I know what I skipped. I have to go down and reveal. We also defined how you can associate artifacts with each other. And so the association is how you can say this artifact belongs to this other object. And so what you're getting at there is that you'd have a signature or an attestation of your container image. You will put the digest of your image inside your signature. And now we've got a way you can query the registry and say, hey, registry, tell me all the different things that point to my image. And it'll give you a listing shipped in the same format that we ship other objects in. That says, here are all the various objects that point over to this image, and then you can pick and choose from your tooling. It says, oh, I see a signature in that list, let me pull that signature up. So you can affiliate these things without modifying the image itself. I had a talk in the past that's talked about modifying the immutable, and this is how we kind of did it. We had an extra call on the API on the registry, and there's a nice fallback as well. If you are pushing this stuff down to a registry, the fallback gives you a way you can ship this out without having to worry about upgrading your registry first. A lot of people that have registries that sit around for a very long time. People in like DoD government agencies might be familiar with this kind of habit. So we've got that. We've also got a data field that we added. So this is where I was jumping ahead to a little bit ago. The data field that we defined is how you can inline some blob data. A lot of these fields that you're passing around in a container image, there is this hierarchical structure where you have the image config that is underneath the manifest. You've got a whole bunch of these layers. Some of those layers are really tiny. There's modifying one file or something in there. You can inline that directly into your manifest to save you this round trip of some API calls to the registry with the overhead that you've got to encode in some base 64 encoding, and now everybody who pulls your manifest has to pull that blob every single time. So you want to balance when you use this for only the really smallest of the blobs. And to make sure that you're encouraged not to throw everything into the manifest, we put a maximum size out there. There were tools already imposing a maximum size on their side. We just defined, expect everybody to be able to support up to this limit, and so please don't go crazy with your manifest inside of a container image. This is not the blobs themselves. All your blobs can be huge. You can have your 2 GB images, your crazy machine learning things. This is just the manifest that says, here's all the contents of this image that you're pulling down. All right, Microsoft also had something. This is like a fire hose, so you got to keep up with me here. Microsoft deprecated some stuff on their side where the legal team had said way back in the day, you can't ship our container images from anywhere other than our registry server that we're going to maintain our side. They all have to come from our server. Whenever you package or ship it, they have to come from our server, which is a pain in the butt for anybody that had some kind of disconnected air-gapped environment. A few people here might be used to some of those. So legal team finally said, okay, we give. We're going to finally let people start shipping around these things. So Microsoft said, we no longer need it for our images. And immediately OCI said, great, we're deprecating this feature because we didn't like it in the first place, and so we got rid of it as soon as we possibly could. If you're using it, please don't use it going forward. If you have some need, let us know, but otherwise, yeah, we're trying to get rid of that. We added Z-standard compression as one of the compression types. It is more performant than gzip, so if you're doing something that's crazy big, you might be able to get some better CPU, some better compression out of this. We added a specification for when you see multiple matches in a multi-platform list. You see like 2 entries in there for the same architecture. If you as a runtime don't know what you're picking from, you pick the first one. And what that's going to give us is the ability that we can add some more data into the image in the future that new runtimes will understand that say, hey, that new thing is something that I actually like, I want to pull. They can pull for some future features, and the old stuff that doesn't know about it can pull the first one on that list. And then we add some registry API extensions. And so for that, we defined how registries can go through and extend, put extra fields in there without interrupting with the OCI specs going forward or with other people who are doing their own specs. We defined how you can resume to chunked upload. And so if you're pushing a whole bunch of data up there, a huge, big, large image with a whole bunch of content in there, a whole bunch of big layer, we defined how you can resume if anything ever goes wrong on the network connection. We defined a warning header out there. If you ever talk to a registry, say the Kubernetes registry wanted to deprecate themselves and wanted to let the users know that they were being deprecated, they could put this warning on their registry, and then everybody that's running a tool that starts pulling it will get this warning up there. Hey, you're pulling from a registry that's about to go away. You might want to update your image references now. That would have been nice to have had a long time ago. We just added going forward, so tools hopefully will get that next time. And we defined anonymous blob mounts. Not a lot of registries have implemented this, but if you have a common base image for a lot of tools out there, those anonymous blob mounts let you be able to say, okay, these same layers are being used by a whole bunch of things. Say the Alpine image is on Docker Hub, but you're pushing to a different registry. Everybody's got the same base image. You can now mount all these things the same. So that's it. Told you it's going to be a fire hose, a whole bunch of features up there. We're up on the GitHub under open containers, and all my presentations are up there. Feel free to reach out if you got any questions. Thank you.